for the next problem, solving by factoring, we're looking for eventually x equals some number. That's how almost all the problems are for this section, using a variety of options. This one has us factoring. The next one has us using quadratic formula. With this one, I'm going to be eventually using factoring, but I'm going to be using a different type of approach because we'll soon see the a coefficient's not 1. So we see parentheses around all of this. We want to try and isolate x. We want to try and move all of our terms to one side. Since we have parentheses, your impulse should be to distribute accordingly. To simplify this, if we take this further, 3 times 2 gets us 6. X squared is along for the ride. 3 times 3x is 9x. This equals 8x, and then plus 12. Moving all of the terms to one side, let's move 8x and 12 by deducting. Imagine that's going to both sides, leaving us with 6x squared plus 9x minus 8x minus 12. We'll take this further and simplify. So we have 6x squared plus x minus 12. This equals 0, keeping in mind because now there's nothing on the right-hand side. And so you might get here and you think that you're stuck. You're not too sure what you can do, but we have 3 trinomials. So previously we've seen factoring. So the issue here with factoring is that our a coefficient is no longer 1. So that's something to keep in mind. So since our a coefficient's not 1, this is how we can still solve by factoring. So a doesn't equal 1, but we're still going to solve by factoring because that's what they mentioned as our goal. And so when this happens, we use a modified version of diamond method where if this, again, is just to organize our thoughts before we make a move and start to rewrite this, where in the bottom part, this is the product of a and c. So the a coefficient and the c coefficient, I'll color coordinate. So our a coefficient, 6, and our b coefficient, c coefficient, which is negative 12. So what's going in here is going to be the product of 6 and negative 12, which is negative 72. And our sum is positive 1. So we're thinking, again, this is our product, so we're thinking factors of negative 72 that add up to 1. There are a few options we have here. You could look at this all day, but eventually the one option that works, since we have a negative product, one of these has to be negative. We end up going to a positive sum, so this is rare. The numbers that work the best here are 8 and 9, only if negative 8 is here and 9 is positive. That's the only way that'll work. And again, you can always check your work because you know that negative 8 multiplying with 9 does get you negative 72. So that's a good check. And negative 8 plus 9 gets us positive 1. So we check that both. That's a good habit to get into if you get stuck. So we know that we can rewrite this x term using these two factors. We were actually lucky enough to see this kind of come into play earlier, seen here. So we'll just rewrite it again as is. So using these factors, 6x squared. The order doesn't necessarily matter that you rewrite these two factors in. Again, it's as if we're just rewriting this x using the two factors that we got here. Continuing to deduct 72. Keeping in mind this is all equal to 0. And so from here, this is going to be bouncing off of the previous section where we're now factoring by grouping. If you need a refresher on that, please go back, check the previous videos. But from here on out, I'm going to assume that you know how to factor by grouping. If we look at the first two terms, we have 6x squared plus 9x. So the greatest common factor there is 3x. So we'll factor that out. leaving us in parentheses with 2x plus 3. For the second set of terms, we have negative 8x minus 72. We know that 2x plus 3 has to appear here again. And if we have this in parentheses, what we need to factor out would have to be, oh sorry, this is back to negative 12, sorry. This would have to be negative 4 that we factor out. We rewrite it to the binomial. There's only one of these we need, 2x plus 3, 3x minus 4. This all equals 0. This is going to be using the zero product property from Algebra 1, where it's saying that out of these factors, one of these could be equal to 0. So this is the zero product property. If you need to look it up, go for it. But it's pretty much saying that we have two factors, 2x plus 3 and also 3x minus 4. And since this is set equal to 0, one of these could be equal to 0, and then that would make the whole statement true. So if we solve this, pretty much an Algebra 1 problem, getting rid of 3 here and here, treating this like two different problems, so we'll make some space between them. This leaves us with 2x equals negative 3, dividing both sides by 2. X is equal to negative 3 halves. If we solve this, we're left with 3x equals 4 after adding 4 to both sides, dividing by 3, 3's cancel, and we also get that x equals 4/3. So for our final answer, we would say that x equals negative 3 halves or 4/3. If we wanted to check our work, we totally could. As we see, there was a lot going on with this because we had to factor by grouping. If you need a refresher on factoring when a is not equal to 1, please email me, ask a question in class. If you need any additional practice, let me know.